Uh, just check, can everyone hear me? Can people online hear me? Yep, sorry about that delay. That's good. We'll just screen share in one moment. Can you see the screen? Where's the recording? Are you able to record? See, or I mean, do you want to try or? Because I need a request.
Yeah, I'm not talking about that.
Okay, so I won't be recording.
Something on Instagram like a day later, it's like, hey, you mentioned this. I noticed that you wore an umbrella. Just in case you can get this out.
Okay, can everyone see that? Yep, okay, in that case, we'll get started and recording's all going. Everyone can hear me on here, right? Yep, okay, in that case, we'll get started. Basically, this will be a mix of workshop in collaboration with CISSA and DSCubed. Hopefully you're a member of one of them. If you're not a member of CISSA or DSCubed, they're both free to join. We highly recommend you join. And also, do you have green sheets? Okay, never mind, ignore that. Basically, doesn't matter if you're a member today or not, but basically, if you're a member, you can get so much free food, free coffee. Does everyone here like free coffee? Yeah, in that case, CISSA hosts diversity every Wednesday during the actual academic year, where you can get free coffee. DSCubed sometimes has a few coffee things on some Mondays, may be coming back next semester. Don't quote me on that. In addition, we both are just dedicated to really introducing students to the industry, connecting and basically connecting students to what is both computing, information systems, math, and data science to the actual industry and the world as well. In addition, hosting educational workshops such as themselves. I'm Harrison. I'm a student as well. So one thing I want to be very, very clear with, do not assume what I say is final or completely true. I'll try my best to present as helpful information as possible. But as I am a student, I'm volunteering for this and I'm not actually taking the subject and I'm not a tutor for the subject. There may be some information that is slightly out of date or as the subject is always rapidly changing. So please always double check information at discussion board with your lecture and with your lecturers, but I'll try my best to present and be helpful as possible. Okay. Basically, we'll start off with a few things on plotting that as well. Basically, what we'll do is I'll try and give a brief overview of everything. We won't go into too much detail just due to constraints of time, but after I'm happy to try and answer questions and talk about different topics to the best of my ability. Basically, we'll start off with graphs and plots. I hope you all know what a line plot is, how to construct it, and what data you'll use it for. Pretty simple. And then we move on to box plots. I did a little turkey because first time I read it as turkey, so I thought it was funny. enjoying that. Just make sure to understand the actual bounds of the data, how to calculate the median and the quartile ranges as well, and just understanding difference between them as well. I'm mainly just giving this to give you a brief reminder in case you forgot about any of these. One thing that also I want to give someone here a quick quiz on. Do they know the difference between a histogram and a bar plot? Box plot, bar chart. Do people remember the difference between them? Because they are similar but different, so it's important to remember. Yeah, pretty much. It's basically the main difference is categorical versus continuous or density as well. But basically just important to remember the difference between histograms and also bar charts as well, which that's need to read that wrong. But basically a difference between bar charts and histograms, because you may be asking that and it's a simple mistake when you're say, depending on how the exam will look like. Just curious, is it in person or online? I'd hope it's in person if and is it the 10th, right? No, not 10th, Monday. 13th, yeah. All the best for that. Then good luck. Yeah, next one is bar charts as well, which is for categorical data, not continuous. And also just make sure to understand the y-axis as well, how they can both be numeric as well. And also another thing to don't forget about bar charts is that there's no order. Whether you have I mean, in general, you may order them by most to least important or highest to lowest, but there's no rules or definitions on order, but that's a pretty minor feature. Next one is scatter plots. These will be pretty important as well, just understanding positive, negative correlations, the actual general shape, and being able to memorize or understand how strongly correlated they are. I guess one way to think about it is correlation strength is just how dense and close it is. For example, with here is you can sort of, I'm not sure if people online can see me, maybe they can, maybe not, but I'm just pointing at the correlation strength. Just one thing, if you asked about that correlation, just think of it as the density or how much you can see lines going on. But saying that though, visual aids aren't always the most helpful. Humans are awful at seeing and understanding data, which is why we have the whole field of data science, so that math and computers do it for us. Oh, also, do you guys cover much stuff on bubble plots? Okay, yeah, that's one of the problems with the subject is it changes so much every semester. Like next one, heat maps you guys definitely cover, right? Yeah, it's basically just a way to represent data in high dimensions because the next graph will cover, I don't think it's covered anymore, but I just want to quickly show you because it's kind of cool anyway. But it's just a way to plot data matrix and can be useful for understanding correlations of different classes as well. You guys don't cover this, right? Okay, yeah, that's a shame because I think they're kind of cool. At least when I did the subject, this was really, really important and they really like talking about it. I'll just give you a brief overview of parallel quadrants just because I think they're kind of cool and it might be interesting. You can kind of see how different objects are related and processes as well and understands how they intertwined and connect with each other. They're not covered, so don't don't worry about them. It's just, at least when I did the subject, they really emphasize them pretty importantly. Do you guys cover much on parallel coordinates then? Okay, never mind then, we can ignore that as well. Basically, it's looking at a scatter plot and understanding how different plots are correlated and how you can understand and just look at data to see correlations amongst them. That's super brief overview of graphs. If there's any graphs I've missed, I do apologize since 2 out of the few graphs aren't actually covered anymore. So apologize for that. But basically, next thing I want to go over is data types. There are 3 primary types of data types: unstructured, semi-structured, and structured. There's basically, way it matters is just how well formed they are. how much information there is. And it's also important to understand how much processing is involved with them. In the case of unstructured, can anyone maybe give me an example of a time they've looked at unstructured data? I'll give you a clue. Do you ever read the news? Does anyone here ever read the news? That's unstructured data, it's text data. A text document is unstructured. Semi-structured forms and some stuff like XML, JSON, CSV. One thing that might be important for you guys is understanding how you can convert from JSON to CSV or XML, or maybe how you can convert, I don't know if you'll cover this, but text data to JSON, stuff like that. I don't think you guys cover that, but in that case, probably pretty important though to understand JSON to CSV, CSV to JSON, and where it might fall through and where it might not be very good. So for example, sorry about that, I don't have an example on that, but does anyone here know what the difference in what a JSON data type and CSV data type might look like? Or do you want me to try and give a super brief example of how the data types might look different? Yeah, sure. There is a good chance we'll get a mark that doesn't work. I'll have two data types. So what's our data doing? What are we trying to look into? Give me a silly topic. Chicken? Okay, chickens. Now we're looking at chickens and assessing their correlation to any other suggestions. Chickens are highly correlated to what? Actually, that's a dumb idea. That doesn't work because that's numerical. Basically looking at chickens and looking at the it's the problem is we won't be able to see because this actually isn't a whiteboard marker. Yeah, I'll try and move this over. Yeah, so move over here and move over here. So say we've got the header, and then we'll say got some data types, so maybe chickens, and then we've got say size of chickens, and then we've got some say information on names of different chickens, and then we've got a bunch of say perhaps some information on the actual say weight of the chicken, so the dimensions of the chicken. So in this case, this chicken is 8 kilograms. This one here is 142,000 kilograms. Big chicken. I don't know. Have you ever seen that? Maybe they exist, maybe they don't. You haven't not seen one, so you don't know. Basically, you have this one here, and there's all a bunch of basically all this information, a few different titles and a few different commas. Whilst here, you might have, for example, chicken. By the way, this is different data type. Camera here. You've got the chicken, and then you've got a here, and then you've maybe got the name. Some data here, close it off, and maybe weight, and then some data, and then close it off. Does anyone know which type is JSON? Sorry, this is not very clear, but basically, does anyone know which data type is JSON? Loosely. Does anyone? Okay, if anyone thinks this one's JSON, raise your hands. And does anyone here think this is CSV? And anyone who hasn't raised their hands, raise their hands. There's people that still haven't raised their hand. No, basically this one is JSON. This one here is CSV. Easy way to understand CSV is it's comma separated something. I don't know what V stands for. Values, yeah, thank you. I just remember comma separated is all you need to know, really. Basically, if there's a commas in it, let's see if the commas, it's a CSV. If it's got squiggly brackets, it's JSON generally. That's probably the simplest way to understand how they're different. And also understanding where you may not be able to convert the data types as well is something you might want to practice. HTML and XML, I understand this is something you guys cover a little bit as well. I guess one thing that you'll probably want to check is when HTML and XML is well formed and not well formed, and when it's like good and bad, and just having a general idea of how they look different as well is probably pretty important to understand. And how we're going for time. JSON as well. So that's an example of a JSON data type. Often key pairs, they're basically a dictionary in Python as well. So that will basically just be a brief overview of all the data types as well. Then we cover this thing over here, which gets into the fun world of natural language processing and just understanding text data and words. I don't think that table is of much importance this semester, right? For calculating distance. Has anyone seen that table before? Okay, maybe it isn't here. But yeah, just important thing, get a bit of practice at this, do a few practice questions, understand how it works and how you can do it by hand if you're asked that. You maybe, at least when we're doing it, we often have to be able to calculate it. Another thing is the actual distance and similarity. Basically just understanding the distance between the words and the different measures. There's Manhattan and Euclidean distance, and I'm not sure if you guys cover any more this semester, but when we did, we mainly just did those two types. One thing to also understand is similarity can be 1 minus the normalized distance, or it can be 1 over 1 plus distance. Just basically, the distance and the similarity can be calculated from each other. They're just a relation or a proportion from each other as well. Another thing to be very important to understand is, and also if I'm going too fast, please let me know, or if I'm going too slow and you want me to hurry up, also please ask, feel free to shout at me. N-grams are pretty important as well, useful for just figuring out how we can break up words in different structures and understand how they work, and also make sure to understand basically the different measures of it. In particular, cosine similarity, super important for vectorization and understanding how similar different words are. You'll find later on as you cover more natural language processing, cosine similarity is everywhere. Basically just write down a few words like the quick brown fox jumped over the lazy dog, or chickens are cool as well. Maybe just try to create different n-grams for simple sentences like that and just try to figure out the distance. Or just like say cat sat on a mat and pat something, I don't know, words that rhyme and similar like that as well will also be beneficial. Next thing to cover, which is a really fun stuff. Personally, I hate regex, even if it is really useful. Who here hates regex? Fair, appropriate response. Regex is really confusing. It is basically just mash all your keys on your keyboard, and that's what it looks like. But it can be decoded. It can be understood. I highly recommend. Does everyone here know regex 101? Or rather the complement of that, the complement of the set. Who here doesn't know about regex 101? Look up the website, you will worship it, you will love it if you've never seen it before. Basically, it's a super helpful way to develop and understand how regex structures work and how it highlights the words as well. Basically, just look to understand the words you're trying to get and just carefully write it out and understand. Are you guys cheat sheets? Oh, that is awful. Basically, just in that case, since it is hard to memorize this, a few things I would understand is start of string, end of string, understand the OR operation, and just understand basically W for words, S for white space. It's a bit weird. And just understand how to figure out the bounds of words. And sometimes if there's any manual practice questions, unironically just use ChatGPT, be like, I need to make regex for this word to find this word. If you're completely lost and don't know how to do it, and then plug and chug it into regex 101 to confirm your theory as well if the words work. One thing to also be careful of is white spaces when it comes to regex, because it's easy to forget about them and actually not factor them in, or new lines as well. But I don't think regex will be super important for your exam, at least I hope not. So if you're really lost, don't spend too much time on this, though double check with your ed discussion if it is. I'm not sure how many practice exams it's been in, but it was important but not super useful. So just wait, you look nervous, and I said, okay, yeah. So there will be a question. Do you know how big it's weighted? Yeah, it's that's what I was just saying is because it's good to know this, but don't stress too much because there's more useful ways to gain marks than just this alone. But it is super important and you'll use it a lot, especially when it comes to working with unstructured data. That's really where regex shines and where it's really important. And to extend onto that, some of the use cases for regex is case folding, tokenization, stemming, lemmonization, stopword removal, text normalization, and noise removal. I'm sure that's a fun thing to remember easily. Basically, it's just making words look normal because English and just all languages are awful, awful data types, and they are a pain to work with because there can be so many different ways to understand and work with the words. Though one thing to also understand in a downfall of where, say, case folding could work and where a problem could arise is actually, let's just say, for example, Bush and Bush. President Bush hid in a bush. President Bush could be the capital word where Bush is the name. That meaning is lost when you perform some form of case folding. So also understand that where maybe text processing can go wrong through the use of, say, these general statements where you can lose meaning in binary words. So just be careful in case you lose some meaning and context behind the word as well, in case you're asked for a pro and con or what go wrong type question. Next one is bag of words. So bag of words is just useful for the vectorization of words. So how you can convert words into a more useful data type, because you could ask, what is a word? How do you work with words? How can you process words? You put them in a bag. You basically just turn them into vectorization you vectorize the words to some degree to figure out and process them. So with that. Another super fun is term frequency inverse document frequency, I think. I hope I got that right. Basically, that's just a measure of how unique words are. It's another form of vectorization and where cosine distance comes into play. Reason why we use this is because, for example, words like the, a, for, and the, blah, 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 those words are everywhere, but they are not important in the slightest regards. They are of no use or real function generally, which is why we use stuff such as TF-IDF to really find the useful words for a data set. It helps us basically find the rare words that are useful for what we're going to find to help infer context and meaning within data as well. Super important, and I recommend just doing a few practice on how to calculate it by hand as well. And are you guys allowed calculators? Okay, in that case, I won't stress too much about this. In that case, the questions probably won't be too hard. Next one is rub calling and scraping. I've heard that that's more important than this semester because at least we didn't give it too much work, but how well do people understand web scraping? Is it understood well or people a bit confused? Yeah, it's I guess depending on times go, I'll give an example after at the end because I personally one of my hobbies is unironically scraping websites for fun. So if anyone wants to talk more with that, and I'll give an example at the end, just in the interest of time. But I will happily talk more about this after. But at the basic level, you have a computer, you call a website, you extract the unstructured textual data from that website, and then you can use different processing to get the useful chunky data that you want out of it out of the website. It's unstructured normally, and you usually work with HTML as well from the website. But speaking of data and the actual extracting data, not really relevant for extracting data, but just data in general, is data linkage. Basically, how you can link records as well and the blocking of them as well, and including more fun stuff such as measuring of distance and completeness and ratios as well. One thing to also make sure you understand is precision and recall as well. just make sure to understand precision and recall, where they're used, and maybe where you may want, and just in general, where you may want higher precision or higher recall. A classic example is always in the case of, say, medicine, where you want to be super, super sure, super, super certain that this person maybe has this disease, and you'd rather overcompensate for more false positives than false negatives in that case, for example. So really, that's just an example of precision and recall. So just understanding and memorizing the formulas, because it is easy to forget at times the difference between them, especially when you're on exam. So just engrave them into your head, just have them written up somewhere, and just stare at the equations for 4 hours. Next thing to go over quickly, just speaking of data linkage as well, is joins. I heard you guys cover a bit of it now, because yeah, we didn't really cover any of this before, so I don't really have much prepared. But basically just left join, right join. They've got 2 different data sets. How you can join them together. Venn diagrams are your friend. You love Venn diagrams. Circles are cool. We love circles, and understand how they intersect and join. Another thing that comes down to data linkage is a bit of privacy stuff as well. And this, just think of use cases with medical records as well, is common. And also just understand the different forms of attacks we can use, such as dictionary attack, frequency attack, how you can maybe use some measures to protect privacy, such as salted one-way hashes, adding in random records, trust authorization only, or different things of Bloom filters as well for approximate matches. Bloom filters are very, very funky. They are weird. So I'd highly recommend, if you're confused, do a bit of practice and maybe ask on ed discussion boards as well if you're still a bit unsure, because they're pretty important, but also very funky. Next thing to just quickly go over is Pearson correlation. One thing that I want to stress heavily is correlation does not equal causation, because did you know that there is a very, very high correlation between Nicolas Cage movies and cheese consumption, I believe, in the US? Yeah, so I'm sure Nicolas Cage, it causes people to eat cheese, or so that's one example. Or another one example would be a bit more grim example is, did you know that when there is peak number of people eating ice cream, it's also the peak number of drownings. Therefore, ice cream causes drownings. Basically, just very, very important to understand that, and just ingrain this in your head if you're not sure, is that correlation is not equal causation. However, it can be used to discover relationships. And that's when we get into some stuff related to causal inference. You do not cover that, so do not worry about causal inference. But it is a very, very cool field later on, in case you're interested. Pearson correlation is just understanding how linear relationships can be formed. This is a nasty looking equation, so I assume you'll be given it if you're asked a question on it. But just understand it's the difference between the value and the mean, and understand the difference between the x and the y, where the y is the true value and x can be like factors determine that, or depending on the actual equation or function you're working with. Just get some practice between working with Pearson correlations and how you can do it. Maybe just do a few by hand. It looks like a disgusting equation. It's not that bad. It's just a distance between 2 objects squared and then multiplying it basically between the x and the y values, which you should be given in a table anyway. Answer. Mutual information is very cool because it makes you sound very smart to say you're working with entropy, because entropy is just a cool sounding word. Basically, it's just how much information you can gain. These equations look awful, they look funky. At the end of the day, it is just a plug and chug. And if anyone would like, for their interest, I could get the camera around. I might just give a quick explanation of what x and y actually are, and a bit of information about this, because if anyone here will be covering probability, this will be important later later on. Is anyone here planning to take probability? Yeah, so basically, and I think actually understanding what X and Y is, and that may be helpful because I'm not sure how well this is covered. Actually, I might see Luke, we might show that better. There are 4 people online. And again, I'm totally sorry if you guys can't see. I've got a black marker for my bag. Yeah, basically X and Y, you don't need to stress too much about the exact details of what X and Y are, but basically they're random variables from a data set. Given that they've already got the data, we don't have to worry too much. Basically you've got X and Y, and you've got stuff like, oops, let me actually do another one. H and Y conditional on X equals X. So does anyone here understand what stuff like Y conditional on X equals X means? Does anyone know how to go? And if you're not sure, that's all right as well. Let's just ignore the function H. Let's just look at, say, we've got a data set of X, Y, and 1, 2, 3, 1, 2, 3. It just might be a bit helpful to think about what X equals X and Y, what that means exactly. So I guess we'll just give a brief example of this. So let's just ignore H and let's just look at the parameters X and Y for now. And it's just some random data. Let's see if this works. I'm just concerned with that. Yeah, this might be what they're doing. This whole checklist here, because this is my marker. So we've got X equals X and X equals Y. So what we're going to do, we'll put these data points here. Give me a number between 1 and 3. 3? Okay. So we're going to take, what are we going to condition it on? 1? Okay. Basically, actually, let's start with something else. We want to find, say, 1 in here. Do you know how we get the value 1, 1? Where is this? Where's the point here? I'll give you a clue. X equals 1, Y equals 1. Yeah, 1, 1. So we're looking at X equals 1, Y equals 1. Basically, what we're doing for stuff like this is the conditioning for your table, just in case you're not too sure, because I was going to be extra careful. Notice X equals X. Basically, this means we're looking at all these values under the condition, all these X values under the condition of a certain Y value. So in this case, Y condition on X equals 1 means we're looking at all the Y values for when X is equal to 1. That's basically what we're doing. We're just subdividing our table up to different sections for only the cases when a certain parameter equals that. So X and Y, they're things called random variables. Basically just means they can be arranged from a different set of random numbers. We don't need to worry about too much. We just pretend that big X is the data table, the data set of all the numbers, and little x is a specific value in it. So just understand, oh, and also when I say values, it can be words such as large or small, as well as the views in here. So when I say values, I'm just generally referring to the actual data type. So for example, when x equals large, we're only looking at the cases when x equals large there. In that case, we're looking at A, and B as well as the values there. So we're conditioning it based on the number of parameters there. So just understand that for big X and little x is just the value we're setting it to. Again, I can go into more detail if anyone wants to understand some of the actual reasoning behind H and all the data that we're working with. I'll give an example after, but just in short, understand the condition, understand how you can make your table smaller, extract a smaller table up on here. Basically, one way to also think about conditioning is each table here has a different number. You are 1, you are 2, you are 3, you are 4. I can then say on the condition that x equals 1, how many people here are see as what's their major, conditioning the information in the major. So I can condition on table 1, count the major, then table 2, condition on that, and factor in that. Basically, that's sort of how it works. And mutual information is just a way to gain information in regards to basically how much you can understand the parameters based on the different tables. It's quite cool when you think about it in how you were gaining knowledge from just some random silly little tables. But moving on from that, sorry, I really like this topic, so I can talk about that stuff all day. But basically, we'll move on to some more of the funky stuff in the basically introduction to machine learning type stuff, which is linear regression and a few other models as well. Understand basically it's linear in function. We assume linearity of the parameters and understand a few of the different measures, such as the squared residual and all those error terms as well. And just understand how you can develop them as well. And one thing I'll also make sure is to understand the difference between yi and y bar and y hat, which sounds funky. Basically, the difference between them is one of them is the basically what we're trying to do in a lot of data topics. This is awful. You've got your true values, which is what something truly is in the real world, and we're trying to predict that. So we're trying to develop a model based on the trained data to then use in the real world. So the different y values might seem a bit confusing, but I don't know which y hat and y bar is the real one, because I've seen some silly examples of used it differently. So now I actually don't know off the top of my head. So this is all for me, but I can tell you that there is one of them is the linear in the actual equation where it's developing the predicting value. You have the real value, you have which is the real world true example, 7 true stone, and you have another parameter which is the one that we're predicting based on that, and understanding the average as well, which is normally y bar. So yeah, y. I don't know if y hat or y is the true values, because I've seen some places that do the notation another way, which is why I need to double check, because I was looking at a different thing and I think I might mess up and say the wrong thing. But just understand that one of them, so y bar is the average, the mean value generally, or some y hat or y. One of them is the true real world value, and another one is the actual value that we are predicting based on our linear equation. So the y value there based on our predicted data versus say what the real world data will be. So understand that there is a difference, and one of them is real world, another is one of them is real world, and another is the actual predictive value that we're trying to predict. Oh, another thing to also remember. Also, would you be able to check the actual chat? Another thing to remember as well is decision trees and where these are used, as well as understanding leaf nodes, the end results, and the end tables as well. I would basically just get a bit of practice at working with decision trees, understand how to split them, and understanding and working with a bit of the entropy and information gained from the trees, because decision trees are just trying to split up data to gain useful information based on it. There's a few edge cases you need to work with, which I can get onto after the workshop, but basically just have a brief overview of the decision trees as well. Not really much I can say on them, so. K-nearest neighbors. So I was talking to some people that were doing the subject. I'm a bit confused on how much you guys cover K-nearest neighbors. Because, sorry? It's not on the exam. Yeah, because I heard that you guys cover K-means or clustering, but not K-nearest neighbors. So as I'm a bit confused on what you guys are covering, then I won't actually go into much detail on this. Just understand that the K is the parameter you choose. That's generally a hyperparameter, and it's how near or how close to different data types are. I'm just not too sure what you guys actually cover based on the fact that you don't cover that. So I don't want to give you guys false information. So I won't be covering in much detail. I apologize for that. One thing to cover also with the models, because I think mainly linear regression and decision trees are the important ones, is just the model evaluation, such as the train validation split or train test split, train test validation split. I see people word it differently depending on what they're doing. Just understanding the model, the parameters you can choose, and understanding what hyperparameters are. Is anyone here unsure what the difference is between a parameter and a hyperparameter? Anyone have a guess? Anyone? Do you want to? I don't know. Sorry to pick you out. No, it's all right. Basically, not sure, basically a hyperparameter is something you said before. That's something the human decides. The human decides the hyperparameter, whilst the computer decides the parameters. So, for example, if we go back to linear regression, how you have all those betas, those are parameters that the algorithm decides. But for example, for stuff like I don't think you guys cover much on neural networks, do you? It's like I will use neural networks as an example just because it's probably the easiest example of hyperparameter, but don't worry if you don't understand. It's just for the actual example. Basically, neural networks have a number of different layers, which determines how complex, how many parameters they're working with, and the data as well. You decide how many layers and how many parameters you're working with. So, for example, you want to determine the difference between a cat and a dog. You can decide, let's just look at the ear shape, or let's look at the colors, or let's look at the weight and size, or let's look at the nose, let's look at the eyes. Those are different additional parameters you can decide to factor into the model, whether it could be 1, 2, 5, 10, 10 million, or in the case of some large language models such as GPT, several billion. Basically, you decide the values to decide for that, whilst the algorithm itself, the machine learning algorithm, such as in the case of linear regressions, decides how much to weight each factors, how much to scale. So it's when you're actually running the algorithm, when you're working with that and the values that are changing, those are parameters. Hyperparameters are stuff you decide beforehand. Basically, in short, human decide a hyperparameter and computer decide parameter, human for hyper. Basically, also for k-fold, also make sure to have some practice at this and bootstrap as well, where you can sample from different data sets, whilst k-fold is partition data set into blocks and using one for validation, average across the scores. Basically, it's just a way to get nice evaluation and metrics for the data you're working with. Another thing to also practice is F1 scores. Basically, just the vroom vroom speed. No, basically precision recall divided by precision plus recall. Just get a bit of practice at write down precision recall and also write down where precision and recall are derived from the true positive, false positive values. Write it both ways, just in case you asked a trick question on that. But just understand that it's a measure, it can be a measure of performance of the actual algorithm itself. Feature selection. I don't think you guys cover chi squared or most of this stuff. I don't think you guys cover anymore. In that case, basically feature selection is in short just choosing how good features you're doing. For example, we're going back to chickens. What do you want to understand about chickens? What do you want to know about chickens? Weight? Okay, so you want to measure the weight of chickens. The color of the chicken might have a determined factor, such as black chickens, or maybe what other color chickens? You've got like brown chickens, then you've got like slightly brown and black chickens. I've never seen a white chicken, actually. Do they exist? Yeah, actually, a good one is yellow. If you're like measuring chickens, if they're yellow, they're probably going to weigh next to nothing. Whilst if they're actually darker colors, they're probably going to weigh more because a yellow chicken is a chick or very juvenile chicken. So that might be a good factor. Whilst on the other hand, the For example, the climate they live in might not be very useful, or maybe you might have a weird factor on how many dogs does the neighbor of the chicken farmer have? For some reason, you might have that data there, for example. That is a feature that technically, in the grand scheme of things, might have a 0.000000001% chance on the actual size of the chicken because might be the wealth of the neighborhood. But that's probably not useful feature to work with. That's kind of an example of what you could do. But just an example of what feature selection is, it's just deciding what's useful for the algorithm because you have different features, parameters, or vectors to work with. Yeah, that's basically what feature selection is. Going back to clustering, and sorry if this is getting boring. We're nearly done. I do apologize. We can ask some more questions after in a more casual manner after if we want to go over and review some stuff, but I'll just start speeding up to try and get through this soon because it's nearly been an hour and I understand you're all tired and it's a hot day. Clustering basically determines how close stuff together, useful for understanding different parameters, especially in unsupervised machine learning. Basically, it decides groups and categories and sets. One thing you use is VAD graphs, and that can be useful to be able to read the graph and see different clusters of the parameters and how stuff can be correlated. K-means is just useful to see how stuff is grouped together to the nearest neighbors. Yeah, it's just useful for a heap of ways, especially understanding how data works and understanding trends amongst the data and how you can decide more useful features. Hierarchical clustering, which involves a dendrogram, something like dendrogram. Basically, just get a bit of practice at how they work, how to actually structure them, and just how to work with them, start from them, and build them down as well through like the linkage as well. There's no assumption to the number of clusters we need, but just basically just do a few practice questions on how the clustering works. This is a really fun topic, which is the good old recommendation systems, which involves collaborative filtering and item-based filtering and user-based filtering. Item-based is basically just, as it implies, the actual item itself, whilst user-based is based on the user. I would recommend understanding where they may differ and where the use cases. For example, Amazon might care more about item-based, whilst Netflix might care more about the user-based filtering, and just having a simple example of where they may differ in use cases. And again, you'll be using some similarity scores as well, which is 1/1 plus the distance. You'll find if you do have time, or maybe if you guys after this want to like form a few study groups with some other people here, again, their obligation. If you write down every single equation we work or almost every single equation the lecture slides, you'll understand they're all very similar, just might differ by a square root or plus or minus. So that's one thing I'm talking about, all these filtering the similarity scores and measures. They're all quite similar measures, just differ slightly on the data. So if you're feeling worried or stressed overwhelmed by the number of data types, I would try not to stress too much because they're all literally quite similar. The distance between all the equations is very small. But yeah, basically just recommendation of systems, understand the difference between item-based and user-based and how you can calculate the scores based on the different metrics and vectors of the data. Now we're going on to data privacy, which is, I swear they started to change out a really stupid meme, but I guess you won't have the meme then, I'm afraid. Basically, how can you keep data anonymous? How can you understand the different types of text, such as homogeneity attack, backgrounds attack, and frequency attack? There's one more. I've got it written down. I'll get that up in one sec. Basically, just understand the different types of attacks and what's the number of records you need to keep people anonymous and the methods you can do such as masking or hiding different data types. And this here you can prevent basically data leakage and ensuring that people can't access the data that they shouldn't have access to. So understand the different, say, techniques you can use to ensure data privacy, as well as the difference between local differential privacy, global privacy loss budget, which is really quite important to understand how much, say, allocation budget you have to guess the true result, and can be a general, it can be sort of like a measure of privacy and security, as well as the global sensitivity. So how can you remove one question which changes the way data is used? For example, and this comes into, just to bring it back to some other topics, how can you say infer information from the data, and how much information can be, say, inferred? For example, we're all uni students, so I basically, there's some information that's all quite common amongst us, which isn't very helpful. One of them could be, I assume we're all of maybe similar age, or our income is negative. As always the case with uni students, that might not give out much information, but maybe I don't know you're well enough to think of any, say, ideas that could provide information, but I guess, for example, how many people here are international versus domestic? How many people here are international students? Actually, a pretty even mix. It's, for example, in some classes you might be heaps international or domestic, or maybe there could be, I can't think of any good examples to my head, but basically just how useful a feature is at determining information or inferring information about someone brings it back to feature selection as well, if you're trying to do this for bad means to try and infer information. But oh, and also one final thing, is it still covered this semester on the different the final topic on data privacy, no, not data privacy, comes through a few ethics of machine learning and data processing, right? Okay, I'll double check on that. Sorry. Oh, that wasn't. Oh, yeah, that's something I meant to talk about. So we did not even touch the topic of IP when I did the subject. So generally, really good that you guys cover it. In regards to IP, if you have the slides up, please correct me if I'm wrong, but understand different types of IP, how you can break the laws and the difference licensing, understand the difference between license, IP as well, and in addition to how IP works and what can go wrong if you do break it, and say how companies can own data as well. When I was doing it, there was like this ethics of data processing. Have they got rid of ethics? Okay, if you don't know, then it's fine. It's, when I did it was the final election, they were like really important, heavily emphasizing that. No stress. If you don't know it, or if you're not unsure of that, then it's not on your topic. So you guys don't need to care about ethics. Ethics don't matter. But yeah, that's pretty much a brief overview of everything. Apologies if it was a bit unstructured. The content has changed a lot within only a year, which is good and bad in their own ways, but hopefully quite good. Basically, I'm happy to just ask general questions people have about, yeah, just about, yep, just happy to answer any questions people have about it now. We'll conclude the recording now as well. Thank you.